Okay, good day, my beautiful students. Today, I am going to give you the summary of periodic motion. Okay, I brought out time to write all these things so that I can summarize this thing under 2 minutes. The video is too big, you understand? So I could not able to post it. So because of that, I decided to summarize it this way so that I can, make it small time. Okay. Now we say periodic motion is the topic we are going to have today. So what is periodic motion in physics? So we say that this is any motion of a body that repeats itself for an interval of time. Now, whenever we say periodic motion, always see this repeats. And see, the motion must repeat itself, okay? And when that motion repeats itself, the period and the frequency of such motion are needed. So you need to get them. That's why we say that the period and the frequency of such motion have to be known or determined. Okay, so we need to determine the period. Then what is period? Period is the time to complete a cycle. You can see, maybe I have this, for example, and I display this thing to this point. When you leave this, you notice that it will go like this and come back, go like this and come back, go like this and come back. You can see the motion, the movement is repeating itself. So this is part of periodic motion. Or I can push this thing, it starts moving in a circular form. You understand? This thing was released from here and it will go and come back to that point and repeat again, moving in a circular form. Is a periodic motion. You can see that that motion is repeating itself. Okay, so the frequency of such motion need to be what? Determined. And also the period of such motion, because the period means the time to complete a cycle, the time it will take this thing to move from here and come back to this point. I released it. Okay, that is the period, the time to complete a circle or a cycle. Now, the period of the periodic motion is characterized by the following. Okay, whenever you study periodic motion, what are those things you need to know about the periodic motion? Number one is what? The motion is always repeating itself for an interval of time. You can see, I release this thing, it will go like this and come back. Complete a cycle. A cycle means, a period means from here, the time you release this thing from here, and it will now go here and come back. The time it will take this thing to move from here to this point, and from here and come back to the initial point, or the time it will take this thing to move from here and move in a circle and come to the initial point you released it. That is what we call a period. Okay, so the motion is always repeating itself. Yes, the periodic motion always repeating itself. Then number two, the period and the frequency of the motion, the frequency of the motion, the frequency of the motion, just put motion here, okay, of the motion would be what? Determined. You understand? So the frequency of this motion must be what? Determined. And the period of this motion is very, very important. So you can determine the period of the motion. Then number three, the acceleration of the body or system must be directed toward the fixed point. Okay, you can see this is the fixed point. This is where this thing is being tight. So the acceleration of this motion, of this body undergoing periodic motion, has to be directing towards this fixed point. You understand? That acceleration is directed towards a fixed point, and such acceleration is a centripetal acceleration, because this thing is being moved by what? A centripetal force. Okay, so that centripetal force is always there to produce a centripetal acceleration. That's why we say that what? The acceleration of the body or system must be directed toward the center, or the suspension, or even the fixed point. Okay, this acceleration is called a centripetal acceleration due to centripetal force that would keep the body in a circle, or in the circle. Okay, so we have number four. Number four says the acceleration is always proportional to the displacement. If we consider the displacement on the horizontal axis, so we use S. If the displacement is what? considered in the vertical axis, we use what? Y, okay? So, but we always consider it in the horizontal axis. So the acceleration is always proportional to the what? Displacement, but in opposite direction, okay? If the motion moves to and fro, for example, the simple harmonic motion, the applied force is always equal to the restoring force. The applied force is always equal to what? The restoring force. Very, very important. That is, applied force, Newtonian force, is always equal to what? The restoring force, okay? So lastly, the displacement of the body is always calculated using this formula. Okay. Now, this formula, either sine or cos, shows that it is sinusoidal. It can repeat itself. Do you understand? So that is the reason why we are using this. In the next video, I'm going to teach you how we can analyze these particular things I said by determining the word, the period. So we are going to know the period of what? This motion, how the period is being characterized. For example, I can say that period is equal to 2 pi square root of what? X over what? Ax. You can see, we are going to prove this, then to show you how the periodic, or the period of what? A body undergoing periodic motion has to look like. See you in the next video.